BIM isn't just a software, it's a whole new way of thinking about buildings and construction projects. It helps us spot problems before we build, make smarter decisions, and create buildings that are more intelligent and sustainable. Hi, I'm Hossan, and welcome to my YouTube channel. Today we're diving into BIM, a term many of you have heard, some of you have worked with, and others still aren't quite sure what it really is or what it's meant to do. In this video, we're not here to promote BIM, and we're not going to just repeat the usual cliché definitions. We want to find out what BIM really is, why it came about, what problems it was supposed to solve, where it's been misunderstood, and where it actually stands in the construction industry today. Whether you're an architect, an engineer, or just curious about the future of construction, this video will help you understand BIM not just as a software, but as a way of thinking. So let's get straight to the heart of it. What is BIM? To really understand BIM in a simple and realistic way, the first thing to know is BIM isn't a software. It's not even just a tool. At its core, BIM is a fundamental shift in how we think about buildings. Instead of just drawing plans, BIM lets us see a building as an intelligent, integrated system, a system that carries real-life information from the very beginning. To make it clearer, let's compare BIM to CAD. CAD is like a precise painter. It draws lines, shapes, and creates a drawing. But BIM goes beyond just drawing. BIM acts more like a decision-making model. In CAD, you see only lines. In BIM, every element is part of a living model that guides decisions. Here's a simple example. Let's take a wall. In CAD, that wall is just a line on a plan, nothing more. In BIM, the same wall becomes a real element, with defined materials, a clear construction cost, calculable installation time, analyzable structural behavior, and even maintenance and life cycle information for the future. This way, BIM allows us to spot problems before construction begins, reduce risks, and make smarter decisions. And here's an important point. BIM isn't just 3D. It starts with 3D, but it goes beyond into ND, 4D for construction scheduling, 5D for costs, and even 6D for environmental sustainability. These extra layers of information make projects more accurate, faster, and less wasteful. According to McKinsey, using digital tools like BIM can boost construction productivity by 50 to 60% because it turns scattered information into a single, reliable source. Why is it called BIM? Now let's talk about the name itself. BIM, short for Building Information Modeling. At first glance, it might seem simple, but if we look closer, we realize that these three words capture the entire philosophy behind BIM. Let's break it down word by word. First, building. This is where many people get it wrong. Building in BIM doesn't just mean a house or a tower. In the world of BIM, it refers to any constructed asset, from buildings to bridges, roads, tunnels, industrial facilities, and even urban infrastructure. The ISO 19650 standard reflects this view, defining BIM as a method for managing information about built assets, not just designing a building. This means BIM isn't only for the design phase, it covers the entire life cycle of a project, from concept and design to construction, operation, and even maintenance and eventual demolition. Second, information. This word is the beating heart of BIM. It's really the most important part. BIM is all about information, not 3D models, not just graphical appearance. Without accurate, reliable, and coordinated information, the model has no value. Trusted sources like MBS and Building Smart emphasize that information in BIM means creating a single reliable source of data that the whole team, architect, engineer, contractor, and owner can access and make decisions from. That's why BIM is truly an information revolution in construction, not just a graphical improvement. Third, modeling. Here's another common misunderstanding. Modeling in BIM isn't just 3D modeling, like computer game models. Modeling in BIM means building an information model, a model that combines geometry with technical, financial, and time-related data. In BIM, form and shape come together with metadata, technical specifications, costs, construction schedule, and different decision-making scenarios. Simply put, a BIM model isn't just pretty, it's functional, simulatable, and decision supporting. When we put these three words together, we see that the name BIM was carefully chosen. It starts with the built asset, focuses on information, and uses intelligent modeling to create an integrated system. The early ideas of BIM go back to the 1970s, when Charles Eastman, often called the father of BIM, introduced the concept of a building information model. But the term building information modeling itself emerged in the 1990s, And by the early 2000s, people like Jerry Leiserin helped make it a global and standardized concept. Today, BIM is part of international standards like ISO 19650, focused on managing information across the entire project lifecycle. Interesting, isn't it? 3 simple words, yet behind them lies a deep transformation of the entire construction industry. The story of BIM's birth. Now, let's take a step back and hear the real story of how BIM was born. A story almost like a historical movie, full of new ideas, scientific efforts, and a journey that slowly turned into a global standard. The roots, 1970s. It all started in the 1970s, a time when computers were just beginning to enter the world of design. During this period, an architect and computer science researcher named Charles Eastman was working at universities like Carnegie Mellon. He noticed a major problem early on. Manual 2D drawings required countless manual updates with every small change, were full of errors, and project information was scattered everywhere. Eastman realized the problem wasn't the drawings themselves, it was the lack of a cohesive model of building information. In 1975, he published a paper introducing a system called the Building Description System. This was a turning point. For the first time, a building wasn't just lines on paper, but a set of intelligent components with defined relationships, technical data, and parametric properties. BDS had capabilities that we recognize in BIM today: parametric modeling, conflict detection, and even automated drawing production. In other words, the foundations of modern BIM were laid there, and that's why Charles Eastman is often called the father of BIM. The 1980s, 1990s, the software era Eastman's idea started mostly as a theory, but in the 1980s, real software tools began to appear. Companies started developing applications that brought this idea closer to practical reality, including RuCaps in the UK, one of the first systems to implement something like modern BIM. Sonata in the mid-1980s, often called one of the first truly BIM-capable software. Later, Reflex, a more user-friendly tool with 3D information-based modeling and even scheduling features. These tools proved that the concept of a building information model was doable, not just an academic theory. By the 1990s, the concept of BIM itself started to take shape. The term building information modeling was first used in 1992 in a research paper by G.A. van Nedderveen and F.P. Tolman. But the person who really introduced the term into professional practice was Jerry Leiserin. In the early 2000s, through articles and presentations, Leiserin positioned BIM as a digital, collaborative process for the entire construction industry, turning it into a global concept. 2000s and beyond, explosion and standardization. From the early 2000s, BIM was no longer just an idea or a specific tool, it became mainstream. Software like ArchiCAD, Revit, and Bentley Systems products brought BIM into the core market. In 2011, the UK government announced an official BIM strategy, and by 2016, BIM Level 2 was mandatory for public projects. This was one of the first major BIM mandates in the world, paving the way for other countries. Finally, in 2018-2019, the ISO 19650 international standard was published, defining BIM as information management across the lifecycle of built assets, and forming the basis for many standards used today. In summary, the story of BIM's birth is the story of a scientific idea in the labs of the 1970s that grew over the decades and eventually became a global necessity. The most fascinating part? BIM was born from a real problem, scattered information, and without anyone initially imagining it, it came and transformed the entire construction industry. The core issue of BIM. What problem was BIM meant to solve and what not? Now we come to the key part. The main question is, what problem was BIM really created to solve? Let's answer this without slogans, without exaggeration, and by looking straight at the roots. The main challenge in the construction industry, or AEC, architecture, engineering, and construction, has always been the same: fragmentation and siloed information. Every team produces its own set of data: architects, structural engineers, MEP engineers, contractors, and finally, the owner. This information usually lives on separate 2D drawings or completely independent files. And here lies the problem. When all this information needs to come together, the result is often inconsistencies, errors, rework, delays, and extra costs. Charles Eastman, the so-called father of BIM, pointed this out back in the 1970s. He said traditional drawings are inherently repetitive and inconsistent because every small change requires dozens of manual updates, and the risk of error is extremely high. This is where BIM was born. The goal of BIM was to create a single, reliable source of truth, a smart digital model that contains all project information, accessible to all teams, where any change is automatically coordinated across the project, not just in design, but across the entire project lifecycle, from design to construction to operation and even demolition. In this context, BIM has truly succeeded in tackling or reducing these problems, minimizing rework and coordination errors through clash detection, reducing wasted time and materials, creating real connections between different project phases, better cost control, reducing financial shocks from late changes, simulating real building behavior before a single brick is laid. According to trusted sources like McKinsey and Building Smart, integrating information with BIM can significantly boost productivity and make costs more predictable. But here's a very important point. BIM is not a miracle, and it was never meant to solve every problem in construction. Many challenges in this industry aren't technical, they are human, managerial, and cultural. And these aren't things that a digital model alone can fix. For example, if the culture of collaboration is missing, even the best BIM model is useless. If there isn't proper training and skill, BIM just becomes an extra cost. Contractual and legal issues, like data ownership or risk allocation, cannot be solved by BIM alone. They need the right legal framework. Resistance to change or high initial costs, especially in traditional organizations, are human, not software problems. BIM can show the problem, but the final solution always depends on human decisions. And of course, BIM cannot solve material shortages, supply chain issues, or a lack of skilled labor. So, in summary, BIM was born to solve information and coordination problems, and in this regard, it has truly succeeded. But deeper challenges in the construction industry, like work culture, weak project management, or economic pressures, are not things BIM can handle alone. Real success happens when BIM is used alongside proper processes, adequate training, and a shift in management mindset. And this is exactly where BIM transforms from a software tool into a professional way of thinking. Misunderstandings and criticisms of BIM. Why do some people speak badly about BIM? Now we get to a sensitive and honest part of the story, the place where many construction professionals either criticize BIM or feel disappointed by it. And these criticisms aren't entirely baseless. According to trusted sources like Dodge Data and Analytics, AEC Magazine, Autodesk University conferences, and real project experiences, most BIM failures aren't caused by the concept itself, but by misunderstanding and poor implementation. Let's look at the main reasons straight up. 1. Poor implementation, the biggest killer. Many criticisms start here. Companies install BIM, but leave their old processes untouched. They think that buying Revit or ArchiCAD and creating a 3D model means BIM is implemented. But without a BIM execution plan, proper training, and a shift in organizational culture, the result is often disastrous. McKinsey reports and global experience show that many projects at the start don't just fail to increase productivity. Teams often feel that we're working more, but not getting more value. 2. Focusing on software, not process or thinking. This is perhaps the most common misconception. Many equate BIM with 3D modeling software. The result? Shiny, beautiful models that are rarely used for real decision making. In the industry, this is called Hollywood BIM or even BIM washing. Models built more for presentation than for information management, analysis, or risk reduction. 3. BIM as a bureaucratic requirement, not a thinking tool. In some countries, like the UK, which made BIM Level 2 mandatory for public projects in 2016, BIM became a checkbox. Models are created just to tick a box, to win a project, or pass a tender stage. This is called tick box BIM or compliance-only BIM. In this scenario, real collaboration doesn't happen, and BIM is reduced from a transformative way of thinking to a bureaucratic task. Naturally, people get frustrated. 4. Heavy models with little real value. Another common complaint, BIM files become too large, slow to work with, and full of unnecessary details. Without proper definition of level of development and level of information, the model becomes a burden rather than a help. Many professionals say this gets worse when teams add extra details just to make the model look prettier, adding no real value to the project lifecycle. The result? information overload, and wasted time and energy. Other issues include high initial cost, software coordination challenges, and cultural resistance, especially in traditional companies or small projects where BIM may not even be necessary. And here's the key takeaway. BIM becomes a victim when it is turned from a fundamental change in how we think about buildings into a flashy software tool or an administrative checkbox for tenders. At that point, BIM stops solving problems and becomes a problem itself. This section reminds us that BIM isn't perfect, but most criticisms are about how we use it, not the concept itself. When understood and implemented correctly, BIM remains one of the most powerful tools in the construction industry. BIM Today. Where does BIM stand in 2025, 2026? Now let's look at today. Where does BIM stand in the construction industry in 2025 and 2026? Let's keep it short, precise, and realistic, not promotional, not pessimistic. Beyond 3D, moving to ND today, BIM is no longer just a 3D model. In many professional projects, BIM has fully expanded into higher dimensions. 4D for construction scheduling and sequencing, 5D for cost and budget management, 6D for energy analysis, environmental sustainability, and life cycle assessment, 7D for long-term facility management. These extra dimensions allow teams to better predict the project before construction, reduce risks, and minimize wasted time and resources. Especially on large projects, BIM is now directly connected to financial, temporal, and environmental decision-making. Real connection to construction and operation. One of the most important changes today is that BIM is moving out of the design office. BIM now connects directly to construction through cloud collaboration platforms, on-site AR and VR, and integration with drones, sensors, and IoT devices. Perhaps the biggest leap, however, is in the operation and facility management phase. Here, BIM becomes the foundation for a digital twin, live models that monitor, analyze, and simulate the building throughout its life cycle. In recent years, delivering the BIM model to the FM team is no longer optional. It's a necessity. Facility managers can now predict maintenance, optimize energy consumption, and manage spaces and assets intelligently. This trend has accelerated in 2025, shifting our view of buildings from constructed objects to living systems. The harsh reality: gap between promise and practice. Despite all these advances, one reality cannot be ignored. BIM adoption worldwide is still uneven. In countries like the UK, according to NBS Digital Construction 2025, BIM use has expanded with focus on collaborative, data-driven processes and even AI integration. But in smaller companies, adoption rates remain low, and in many countries, BIM is still mostly limited to large or international projects. Old challenges persist: shortage of trained personnel, high initial implementation costs, software interoperability issues, and cultural resistance to change. The truth is, the construction industry remains one of the slowest sectors on the path to full digitalization. BIM promises a data revolution, but in many projects, its implementation is still superficial, incomplete, or purely for show. To be fair, BIM today is more mature, more powerful, and more essential than ever, especially with the rise of ND and its deep connection to digital twins. But the gap between BIM's true potential and what is actually implemented is still significant. Real BIM success is no longer just about software. It depends on long-term investment, serious training, and most importantly, a cultural shift in decision-making across the construction industry. Perhaps today, more than ever, BIM is a mirror that reflects both the weaknesses and the maturity of our industry. To sum up everything we've discussed, BIM is not just software, it's not a passing trend, and it's not an administrative checkbox. BIM is a change in the way we think about buildings. From the day Charles Eastman introduced the idea of the building information model to today, where we talk about digital twins and lifecycle management, the core issue has always been the same: the right information at the right time for the right decisions. BIM was born to reduce information fragmentation, increase coordination, and help us think smarter before construction even begins. But as we've seen, BIM was never meant to solve all problems in the construction industry. Without a culture of collaboration, without serious training, and without decisions based on insight rather than guesswork or time pressure, even the best BIM model can't achieve much. Today, BIM has reached a point where it cannot be ignored, yet it is still not fully understood. And perhaps the most important question isn't, are we using BIM or not? It's, are we really thinking in BIM, or are we just using its tools? Ultimately, BIM is not the future of architecture, nor the future of engineering. BIM is part of our professional maturity in the construction industry. And the deeper this maturity grows, the more the buildings we create will become less wasteful, more sustainable, and more human-centered. Thanks so much for staying with me until the end of this video. If you found it helpful, please don't forget to like and leave a comment. Your support really means a lot to me and gives me the energy to create the best content for you. Thanks again for being here.